Hi, I'm DJ Ware. On this episode of the CyberGizmo, I'm going to go back and do an update from last year where I talked about how I use ARM in my home lab. You're probably going to be surprised. Stay tuned right after this. So, I originally did this, I think it was toward the end of last year, where I talked about how I was using ARM in my home lab and basically what my home lab looks like. So I'm going to share that with you again. I have made some updates, but let's talk about where it is right now. So whenever we talk about the past in architecture, we talk of as is. So this is kind of the state of the system. Nah, not exactly. I mean, I have made a few changes to this, but not a lot. So basically there are 4 networks. So the first network at the bottom is the risk net. So that's the one where all the dirty stuff is, the IoT devices, the media server, all of the things that I just don't trust. The wireless, that's all, the Wi-Fi network, that's all down there. So don't trust that at all. Those systems don't come up and touch anything else. And the middle part and the white part, I had that originally just kind of lumped together. Those are servers that provide security, login, auth and auth, DNS support, all the infrastructure kind of stuff for the network, and pfSense, of course, is out there. And then above that is the StoreNet, and of course I have to partition that off because Gluster is chatty. I don't want the traffic on the production network. I'll get enough of it when I go to do stuff that come across that network, but I'd rather those servers just stayed over there and did their thing on that network and didn't spill over. So, and then finally, the x86 net, which was the original way I showed this, which was all of the machines that had now originally that was a NAS that was on a ZFS NAS that was on FreeBSD. So that's changed. And also the Docker production network, the Docker test, the OwnCloud, all of those things were on XCP and G at the time that I did this. I have removed that and gone to Proxmox now, and we'll talk about some of those changes. So so this is the state of the system as I want it to be, and I'm going to kind of change things up a little bit and kind of lock things down a little bit more and make things a little bit more secure. So I guess probably you'll notice that really the number of networks is looks like it's expanded, but not really. So I'm going to call the first part of it the EdgeNet, which has pfSense and then the ISP's router. I'm just going to kind of block that off and push it out to the front. I'm going to create a border net, which has all of the things in it, and a guard. I'm going to start using it as a real guard, which does not allow traffic to pass unless it is permitted. So so you configure that. There's a number of features that are in those. If you're interested, I can go through that with you, but I'm not going to do that today. And then there's an AI server that I use to basically monitor the traffic, look at it, make sure that there's nothing malicious coming in. Audit logs, I use that as well. The AI server looks at those as well and will send out alerts if it finds something that it doesn't like. The bottom part, the radius server, DNS server, auth and auth servers are down in that neighborhood. So all that stuff is kind of together on that network. So you might, in a more formal setting, in a corporate setting, you might think of that as a management network. StoreNet hasn't changed at all, the green one, and then the blue one. I've shifted this over to call it a ProdNet, and this has changed somewhat as I have said, but we'll go into that in more detail in a minute. The RiskNet, I have removed the television off the network. It's gone. And so, there's no need for that anymore down there. So that is unplugged. I don't need that headache of things coming through that way. So, and then air gapped is something I am planning. I don't have that one built yet. I'm just planning it. So first of all, I'm not taking a contrary position about ARM being good or bad, but the way the current versions of SBCs, which is what I'm using, have in the past been pretty slow, but the cost is a lot less than an x86. I mean, I can buy an awful lot of ARM machines for the price of one x86, and if you're trying to limit the number of applications per server, it doesn't make sense to deploy x86 in low CPU overhead applications. That's just wasting a box. So yeah, I could pile them all onto the Proxmox server, but in some instances you kind of want to have those systems as hardware. And so yeah, that's the main reason for doing that. So ARM doesn't have a lot of RAM, but that's okay. I mean, again, manage your applications to the ARM, and that's fine. Now originally when I did this, it was only up to 4 gig. Well, now it's not. It's up to 8 gig now. So that has changed a little bit. For desktops, yeah, the RAM, it was an issue. However, that's not anymore. So anyway, the AT&T Bell Labs mantra, 1 application per server, that is the old Unix mantra that we followed when I was working for AT&T, and throughout any kind of work I did with Unix. It's kind of followed me around ever since that. Now that doesn't count when you're doing service-based application deployment or container-based, because you can certainly get a lot more applications onto a single piece of hardware, and especially when you have 56 cores or 96 cores. So how do I use ARM? So right now my focus has shifted somewhat. You can go, I'll leave a link to the other one if you want to see. I have moved some of the servers off of ARM, and I have moved some servers onto ARM. pfSense has always been on x86. The ARM is fine, but I have too many networks for that. So trying to find an ARM box that has that many network connections in it, that's just difficult to find. The Guard is x86. Again, that is I guess for it's a screening router, basically, is what it is. It has a couple other features in it, but it's basically, for a lack of anything better, it's a screening router. Audit log server, now that's a very oversimplification actually of what it does, but audit server, log server is a Odroid N2. Radius server, audit is a Odroid N2 as well. DNS server, RPI4, I have upgraded those. They were, I think before they were the Tinker boards. I never could get much performance out of those. They seemed to overheat long before they would actually perform very well. But the RPI4s have been doing quite well, or at least in my network. They seem to be doing fine. Auth and off, RPI3. I probably will move that over to an RPI4 at some time, but for what it does, it's fine. AI, NVIDIA Jetson AGX Xavier. I was using a Jetson Nano in that space, but it got swamped. So I moved it over to the Xavier, and it seems to be working a lot better there. Much happier. It seems to be much happier. StoreNet is Gluster FS. Now that is running on Odroid, HC1, HCT. You probably know that I've talked about those before. I don't know if I'm going to move to the HC4 or not. I mean, they're working fine. They do a great job for what I want, and so I'm just going to leave it there. Prodnet, the NAS, I have moved that off of FreeBSD. It is officially on OpenZFS 2.0 on Linux, so it is running over there. Proxmox x86. I have a Docker production, and I don't have a test server there anymore. I'm going to move that down to the air gap. OwnCloud is running there, and Ansible server. So that really is my production network. Now, the Ansible server is used to maintain all the machines in the network. There's a source code server that I use. It was on ARM originally. I have moved that to x86. I probably at some point are going to deploy it. The reason why it's not in Proxmox is because the original Proxmox server I've had in there didn't have enough memory or enough cores to really do the job it does now. So I may take CloneZilla and go. In CloneZilla, you can take a hardware-based machine and create an ISO out of it, and then you can import that ISO image into a VM. Pretty nice. So, and I think VMware's got a tool that does that, but I remember trying that a few times, and I just never had much luck with it. It just never worked right, at least not for me. RiskNet, media server, x86, IoT devices. There's a controller that runs on Odroid N2. That's managing all the fun stuff in the house. There is going to be a DL server planned. What I intend to do there is have I may have 2 different operating systems that I'm running in production right now, Ubuntu and Debian. So either I've got to make a choice and get down to one and bring, or I can set up that DL server to service updates for both. I think I can try that. I used to run an update server for, I had about, I don't know, 18 Pis or something like that at one time, and I was using for MPI. And I used to create one of the RPIs as a update server, so it managed the basically all of the packages and everything. And so instead of the Raspberry Pis going out to get the updates from the Raspberry Pi Foundation, which is what they would normally do, they go to the server that's local and pick up all the stuff there. And so I only have to download it once. I got kind of worried about, I mean, I know they're at the time that they were kind of limited on funds, and it wasn't always the fastest to do things. So I thought, well, I'll just hit it once and I'll get the updates, and then I'll just propagate them out. So I'll probably do something like that again is the intent. I am not going to take those and pull them directly into the servers, however. I'm going to take those and sneaker net them over to the air gap. And the air gap has the intake server, which is where you can look for you can scan it for viruses, you can look for malicious malware, you can quarantine it there for a while and just see what happens with it, see how it affects the server. Not sure if I'm going to need 2 or 1 yet. Again, it's all in the planning. Outflow is that is a server that once you're satisfied with it, the test is everything is working, then you go to the outflow, you pick that back up, and then you carry it up and put it in your software control system, and then let Ansible disperse it from there. So that's the plan anyway. And then a test NAS, OpenZFS, already have that set up. It's ready to go, and that's on an x86. It's very small. It's not very big, but it doesn't need to be for what I'm going to be putting over there. Test server is planned. I'll probably have to have 2, one for x86 and one for ARM. I don't like to do testing as an emulation mode on x86 for ARM. I just don't like to do that. I have run into problems before, and so I don't really want to repeat that. Desktop, based on ARM, I do have one. It's an NVIDIA Jetson AGX. Now that is the older AGX, not the Xavier. It's a big blocky looking thing. It's fairly decent performance with XFCE and also KDE. GNOME, however, no, not a good choice for that machine. It's just too slow. And it might be the fact that there's I don't know if the 3D, that graphics chip is really meant more, it's heavier on TensorFlow and machine learning and doing CGL, and doing CLI programming. So it's the computer, well, anyway, you're running your computer code inside the graphics engine. But as far as graphics performance, I wouldn't want a game on it. It certainly isn't tuned for that. So why am I adding this air gap net? What is that all about? So I don't know if you've been following the news. I'm sure you read about the breach by now. But on Monday, FireEye reported that they reported that they had been breached, and a number of other government entities had reported that they had been breached as well. And the breach goes back to, I think, either May or June of 2020. So it's been gone undiscovered for a long time. And it turned out, I think the early reports from FireEye are saying that they believe that the way the breach happened was through, of course, application software that manages the network, and that is the Orion software package. So that comes from SolarWind. So and whoever the perpetrator was, I think there's still some doubt. I mean, they'll find out, but there's still some doubt on who did it. But very clever hack. They actually, it looks like either they got the keys or they were able to emulate them very closely, so that now it was on Windows, and so that when the update took place, as far as Windows was concerned, this was an authorized update with valid keys. So yeah, this isn't the first time this has happened on Windows, but this could also happen on Linux. It's possible if somebody gets a hold of the private keys for the application for the repos, game over. I mean, they could put in there whatever they want. So the same problem could happen on Linux. It just hasn't yet. am I really concerned about that? No, but I just like, I mean, there's a couple of reasons why I want to do the air gap server first. I don't want to just let something loose in the network that might be broken, might have a bug in it. That's always a possibility. And that usually is the worst case that happens for me, is that you get a bug loose in the system, and then because most of the systems are the same, it doesn't affect just one of them, it affects 18 of them. So I don't want that. So I want to keep an air gap system, and I'll just do that there, and then I'll bring them back out and I'll do it. It's kind of the way that some of the trusted networks work in high security environments, is that you usually do air gap and you don't interface to any external networks at all. So that's what I'm going to do, and then I'll do the updates there. I'll scan them for malware out. Probably going to move one of the AI servers in, not sure yet, and that will then do additional malicious tracking, and also we'll look at stuff. But it also requires a log server to go with it, so I don't know how far I'm going to go with it, but we'll get there. I probably should do the log server. I probably should do the AI server, but anyway, I'm still planning it, still drawing it out, trying to figure out how much I can get done this year, in the coming year, not this year, but the coming year. So yeah, and then there'll be an outflow server once I'm satisfied that everything's cool. So basically, you're quarantining those application changes to a closed environment where there's no escape. If it's in there, it could destroy anything at once, but it isn't going to get out and do anything else, do any other damage to the system. And there'll be instrumentation, and there'll be log files that I'll be looking at. So, I mean, it's the best I can do. I mean, people have been getting really more and more clever about how they do these attacks and breaches. And anyway, I don't have anything worth stealing, so if you want to break in, go ahead, but you're not going to find much. There's just not much here. This is just fun for me. I'm just doing this because I want to try something new and play around with it, not because I'm paranoid, but I just like to play with new things and just see how they work. So that's the reason why I intend on doing that. So I have run into problems with ARM. So just to reiterate this, running ARM as a desktop or something, I have run into problems with PPAs. The PPAs can be problematic, particularly if you're doing upgrades between one release to another major release. For example, there's the one that runs the little video behind me here. That is an Odroid N2. That has some issues. I cannot take that to Ubuntu 2010 because at the moment one of the PPAs is messing it up, and the PPA happens to be the kernel that comes from Odroid. So yeah, so I'm kind of stuck there. I could go out to Odroid, I could re-download it and then just fix it that way, and I might do that at some point. I'm in no hurry. It doesn't really bother me that it's not on 2010. It is on 2004, and that's still supported, so I'm fine. However, for a server environment, I haven't found that to really be an issue. I only run one PPA on the ARMs in the Gluster network, and of course that's for the Gluster FS server code, and the client. That's it. That's the only thing that comes down. Those two pieces are all inside of one PPA. The Gluster FS folks are really good. I don't know what it is about them. I mean, if they do an x86 release, the ARM release is right there with it. I mean, they don't waste any time. It's like they understand that some of us weirdos are using Gluster on ARM. I'm sure that some of their customers, some of the larger customers, are probably using using server-based ARM. So, but I'm glad that they take the time to get it out first, because it's nice not have to wait when you see something new that you might want to take advantage of. The Mali-based ARM GPUs are okay, but the performance isn't great. And like I've said before, if you've ever done any development on Mali, you know that it's really difficult to find the little tricks that you need in order to speed things up. Yeah, they publish an API, but if you follow that, you'll have a very non-performant system. So, but there's well, anyway. Mali is very tight-lipped. Their documentation is closed. They just don't share. So, the only applications which I find that really suffer our ARM are the ones like virtual machines. Of course, they don't work well because there's just a lack of memory and a lack of cores. Now, containers, you can run a couple on even the smaller ones, so that's not really been a problem. I have run containers on them before, and they run just fine. x86 machines is my choice for virtual machines because you just need more memory, you need more cores, and you don't have that yet. Although I think this year that probably will change. For DNS radius server, now radius server, as long as you're not doing too complex a crypto in there. But if you get into the really complex crypto, I mean, it's just going to affect your login time. So you might wait maybe 5 extra seconds or so to get in. LDAP's not a problem either because same deal. You don't keep going back to the LDAP server every 5 minutes. Unless you like to log in and out a lot. RLog, of course, I don't use a version of RLog. I use something else. But I haven't noticed any performance differences. And in fact, I have run things like Elastic, and I have run things like Solstice, and I have run things like Logstash on ARM, and those run just fine. Never had any problem with it. So for Kerberos, however, x86 is better, and I think it's more because of the implementation version is a little bit newer, and but it also could be because there is some key management that goes on in Kerberos that is a little heavier than normal than some of the other methods that you can do. You don't have to use Kerberos. I just choose to do it. For Ansible, there's a noticeable difference between ARM, and there still is. I don't know what it is. There's some real strange behavior in ARM. It is slow to start up, but once it gets going, it's fine. But it's like that ramp up where it goes through that initial checkout when it's looking over the machine to find out what's going on before it actually starts up the task. Now this has to do when you're running the playbooks, but if that's the only thing I've ever seen is that x86 will definitely outrun it. Duh. I mean, it will definitely outrun it. So yeah, and I don't know. To be honest, I haven't tried it with the RPI4. And it might have just been the botched up network stuff that the RPI3, because it's actually, it's a 1 gigabit connection, but it's only 200 megabit performance, and then it's tied into the USB ports on the machine as well. So which were at that time USB 2, I believe. So yeah, but anyway, it's a lot faster. I just haven't measured it. I haven't done any benchmarks on it to tell you. So how do I use ARM? I use it for servers. I do follow the AT&T Bell mantra. One server, one app per server is what I do. Desktop performance on ARM, NVIDIA, great. I mean, I don't have a problem at all with that. It works fine. Anything else, if it's Mali based, nah. I know people are using RPIs and trying to use it, but they're struggling. Every time I see them doing video, and it's like, oh, there's a drop frame, there's a drop frame, there's a drop frame. Sometimes, I think for HD though, it works okay. When you get into 4K, it's just dropping frames everywhere. So that's kind of a problem with the Mali chip. That hasn't got anything to do with the ARM itself. That's just the Mali. I did try that on the NVIDIA. I didn't experience that problem, but I didn't really get it too much to work under 4K with it, so don't know. PPA issues, I do run into those from time to time on the ARM, but so I try to minimize those by not using them too much. Is there Flatpak and app image and snaps for ARM? There is snaps for ARM. If there is Flatpaks, I have not used them, so I don't know if there is or not. There might be, but app images, yeah, there's a few for ARM. So performance overall, Ansible is okay, but it's slower on ARM than x86. Kerberos is slower on ARM. I think that's just because of again, either the network or just the cryptography that's going on in it is a little bit more strenuous key management. Other apps that I run, I don't see much performance differences at all. Now, this is on a server. DNS, I mean, the latency on a DNS server is it's only, if it's a millisecond, I'd be surprised. It's probably more in the nanosecond range. It's very quick in returning. It's going to be, your network is going to slow you down more than the server is. It's usually pretty quick in response. So that is all I have for today. The one comment I was going to make is that I noticed that the government's response to I guess they're going to call it, is it sunburst? I think is what they're going to call it, and is the malware. But I noticed that one of the things I thought was kind of hilarious was that the thing they were saying was, oh, just shut down Orion, you'll be fine. No, I don't think so. I mean, the first thing a hacker's going to do when he gets inside is make sure he's got about 5 or 6 different ways of getting into the system after you close the main one when you find it. So now they're going to have to go cleanse those systems, and I would imagine they'll probably end up nuke and paving them in order to get them back up into working again. But this ain't over. This ain't over. They also, I guess the guys that broke in also stole the red team tools from FireEye, and FireEye immediately, good on them. They immediately released code that will block those red team tools, because there are some ways that red team, you're really pushing to try to get malware onto the system, or to break something to be able to get further into the system. So it's good that they have put these blocks up. I noticed that there were snort rules, and there was some other things that were in there as well. So if you're concerned about it, go download it. I had an update this morning for pfSense on the snort rules. So I'm going to check, going to compare the two later on, maybe tonight, and see if they're in there. If not, then I'll hand code them in, or just copy their file in, one of the two. But anyway, that's all I had. I hope you enjoyed this video, and if you did, please like and subscribe. Hope to see you all again real soon. Bye for now.